Hi, I'm Lanisha Robinson, your host for Career and Technical Education, #BuildAFuture. Working in St. Lucie Public Schools with the Career and Technical Education CTE department, we want to show what our teachers and students are doing in the classroom to close the skills gap in multiple fields. The students in these programs are earning industry certifications, which create more opportunities and options for all students after high school graduation. In this upcoming episode, you will meet Mr. Cobb from Fort Pierce Westwood Academy and learn more about the Applied Robotics program, which is a part of St. Lucie Public Schools. All right, welcome. Please go ahead and introduce yourself and share your role at Fort Pierce Westwood.
So my name is Cobb. I am the engineering and robotics teacher at Fort Pierce Westwood Academy, the West Prep magnet. At that school, I am the teacher of the engineering and robotics program. So I cover topics from robotics to electronics to CNC, 3D printing, rapid prototyping, as well as several other engineering areas.
Okay. So, because you work at IRSC as well?
Yes. So at IRSC, I am an adjunct teacher for a robotic and electronic program there as well.
Okay. And you've also had training with them as well, like over the summer or anything like that?
Yeah, I did a full actual 2-year program there with the electronic and robotic program and photonics.
Okay. So what do parents and our viewing audience need to know about, excuse me, the learning experience from your students and in the classroom? What do they need to know?
So the really unique part of this program, whereas in most educational environments, there's a lot of the teacher gives and the student gets. A large part of what I do is hands-on. So the students learn by actually doing, not just learn about theory and doing notes and things like that. So one example is they learn by working with things like this here, which is a electronic programmable circuit. So they can actually put this together, put parts on it, and understand how they work, take measurements, as well as test it. So that's a large part of what I do is hands-on, which is different than most classrooms.
All right. So some of the things that you mentioned, the hands-on experience with your students. So if we were to come into your classroom on a typical day, how does that one period go? Like, how do you transition them to the hands-on experience?
So typically for the first half of the class, it's we're a 90-minute block. So 45 minutes is typically instruction, like a typical classroom. The second 45 minutes is typically a hands-on lab that is based off of the first half of the class. So whatever we covered in the first half would be what they would actually participate in the second half and test and run with.
Okay. All right. So one of the key things that we have is Mr. Newton from St. Lucie West Centennial created a video with his students to actually showcase and highlight some of the things that you all do in the classroom. So we're going to take a piece. We're going to look at that right now. All right, so Mr. Cobb, with the classes and courses for a student actually taking the robotics program and to actually complete it, what courses will they need to take?
So the first course is Foundations of Robotics, which covers the basics of electronics, how electricity works, how current works, some of the basic things with mechanical, parts of robotics, sensors, as well as AutoCAD, which is a type of CNC printer, or it's a design software for a CNC machine, which is able to cut things into wood and design items like that.
Go ahead.
The second part of the course is robotic design, which goes further into electronics and electrical theory, further into the robotics aspects of actually programming them from between C+ to Java. And the third and fourth part of the program are learning more about the 3D printing aspects of rapid prototyping. And the last part of the program is actually a capstone project where they will actually complete a larger project from everything they've learned in the last 3 years.
Wow, that's a lot.
Yeah.
So with that being said, you had actually brought in some items to share, and these are items that your students actually created in the classroom?
Yes, so
Okay.
most of these are actually student created. So one of the first things we have right now is a Lego EV3 unit, which this is for my robotics foundation course. This is my freshman students. With this is actually a self-driving car. It avoids obstacles, it does all of that. So they learn how to obviously build it, which takes a little longer than you would think. From that, they learn how to use the sensors, which on here are the ultrasonic sensors and color sensors. And they also learn how to program it, which is done in a language known as block programming. So it's graphical, they can drag and drop, which later they learn how to convert that over to actual legitimate computer programming rather than just dragging pictures back and forth. Some of the other things I have up here that students have created within the course of the program, they learn how to do 3D printing, which these are being created currently by my first robotics team students. So they are a competitive robotics team. These are some of the things they'll be using this year in competition. These are basically a 3D printed Lego block that they will have to stack in a tower as tall as they possibly can. So they printed these to be able to practice with that.
Okay. So just a question about that.
Yeah.
So you're telling me that your students actually printed this from a machine in your classroom?
Yes.
Okay.
So we have 3D printers in the classroom that they actually used a online software to create and design. There was no template for this. They had to do it on their own. I'm very big with that. For the students to learn, they have to actually do trial and error. They have to actually do it themselves. Us feeding it to them doesn't get it there. So this took 3 tries. And this is the third model of it here, and they actually are fully interlocking, and we can knock them over and all of that. Something else that the robotic team is doing right now, and this is more the advanced robotics past the Lego, is a system like this here, which this is going to be our competitive robot. The purpose of this will be to be able to lift and drag items and stack items. So this is more advanced. This is more Robotics 3 and Robotics 4. This will have sensors on it as well as a full crane arm and grab at the end that can lift things and drag things.
So how are they doing, what's the process that the students have to go through in order to make this item actually move and do what it needs to do?
So the process for this was we started out on an actual practice session brainstorming what we wanted to do. The students got a general idea based on the problem that was in front of them. From that, we have a mechanical team which has a leader. We have a programming team with a leader, and then we have our compliance and field team, which is in charge of making sure everyone's following the rules and making sure everything's in order. So from that, right now the mechanical team's about done with this. This is still about another 1 or 2 sessions from done. The programming team will take over and begin programming all the aspects of it, which will be the things like the drive motors underneath, as well as the arm motor, and then there will be an actual claw motor up here as well that they'll have to program. From there, the compliance and field team will be in charge of making sure as they're testing it and running it, it's following all of the rules and compliances of FIRST Robotics.
Okay, so you've explained a lot. There's like a huge process of what students will have to do from the very beginning, actually drafting it, designing it, coming up with a possible solution to a problem that you actually address. These are real world problems that you're actually providing to your students.
Yeah, so that's the one nice thing about the organization we're involved with, FIRST Robotics, is a lot of their problems and projects are based off of actual real world application. These are skills that they can take into industry when they leave Westwood, and they can actually apply in a real world environment.
Nice. And so what other fields are out there that they can actually take the skills that you're learning right there in the classroom at Fort Pierce Westwood? Where else can they go with this?
So there's a lot of different places they can go with this. One of the bigger fields in the area, we have a lot of companies that are using CNC machines, which one thing they learn how to do is actually use a CNC machine, which is based off of AutoCAD, and they learn to certify in AutoCAD. This is an example of what a student did last year. From this, they design it within the software, and they learn how to run a CNC machine. If you're not familiar with a CNC machine, there is a drill bit in the controller of it that the students have to program in tool paths that it can follow and carve into the wood. So it's very delicate. If you're off even a little bit, the whole thing is off. These are actually, this is done on particle board, which is wood. In industry, this is more with metal and steel, which for prototyping purposes has to be very, very precise. Some of the other industries in the area that we have, especially in Melbourne and the Space Coast, is the space industry, which is looking for electronic technicians all the time. There's job postings going up every single day for those. Electronic technicians need to know how to solder, they need to know how to use electronic circuits, how to program to some degree, how to do some wiring, which is a large part of what's covered in Robotics 1 and Robotics 2 is the electronic theory and the actual application of the theory.
Okay, so to go along with that, basically I'm hearing that students are able to basically, are they certified in anything, industry certification that you offer?
So they will leave me certified in AutoCAD user level, Autodesk Inventor, which is the software for the 3D printers, and Autodesk Revit, which is a more architectural design software. They will also leave me certified with the Robotic Education Association curriculum for pre-engineering, which covers electronics, mechanical, as well as several different other entry-level engineering aspects, as well as a robotic certification that says they've been heavily trained in both electronic, mechanical, and computer programming.
Wow, that's amazing.
Yeah, and those are state-recognized certifications, so they're not just, they're real. They're actually usable.
So with being usable, that means your students can actually leave Fort Pierce Westwood, leave your academy, graduate, and then go and attain a position working?
Yes, and we have already had, and this is our second year of the program. So we have, last year and the first year, we did have seniors that took the course. From their experience, I do have one right now that is working in a technology position, and another one that, based off of his ASVAB scores, from learning just the basic electronics, qualified to go in the military as a radar technician, which was a higher paying area and something more of interest to him, which was a great opportunity for him.
Wow. So with that being said, do you ever have any opportunities where your students go off campus?
Yes, we are working with those right now. Last year, we went to Indian River State College to their robotic program. We also went to Florida Polytechnic to explore their electrical engineering program. We are in the process of setting up different visits for the first robotics to go out and test that. And we are also trying to set up a few industry visits with different companies so students can actually get an experience of what is out there locally.
Okay. So as an educator, why is that important to take students off the campus and actually see what else is out there?
Well, for a lot of students, they've never actually seen the industry. You don't just walk into factories, you don't just walk into places that create satellites. So when they first introduced this, they're like, okay, this is out there, this is cool, but how do I use this? And with right now, the big push for years has always been you have to have a bachelor's, you have to have a master's degree to actually pursue engineering, which once we take them into those places and they see, well, no, I can actually become an electronic technician with a high school education or very basic education past that, which is critical because it shows them what's there and what they can actually do.
So with that being said, looking at employment, do your students or do you ever cover soft skills, employability skills, and those importance of having that in there?
Yes, a lot of my, or not a lot, all of my projects are based in teams. So I actually have them constantly working in teams. So they are practicing those teamwork skills, the communication skills. Typically the students in the teams have roles of their own. As I said, with my robotic team, we are actually set up with a leadership team that I have a person in charge of everything, as well as people that are in charge of the individual teams and their progress. So yes, the soft skills are critical, and they're something that I put into basically every single project.
Okay. So with the Robotics Club that you all created, how long has it been there since the previous year? Because I know you mentioned that this year 2 of the program.
Yes.
So has it been there for 2 years? And then how does
We started the Robotic Club last year with a small group of students that were interested. We learned a little bit about the CNC machine and 3D printing. This is our first year participating in the first technical challenge, which is the large steel robot over here. So this is year 2 of that, and the first year of competitive. It's planned for next year that on top of first, we're probably going to participate in another competitive competition that we're still working out the small parts of that, but it is the plan to continue to grow it.
Okay. So with that club, do you also have, because you mentioned leadership.
Yes.
Is that something that they just say, hey, I want to be an officer one day? Or how does that work with your students? And why is that important to actually possess leadership skills and qualities now at the high school level?
So the student that's in charge of everything I've had for 2 years now, she demonstrated a lot of leadership in the class. So I actually had hand chosen her to be the leader of everything, of the club itself. The people that are over the individual teams demonstrated interest. They asked to be in a position of leadership. They wanted to grow themselves. And those individuals were able actually to demonstrate that they had the drive to do it, and that's my primary concern. I can get you the education, I can get you what you need to know. If you have the drive to get there, then I will get you what you need to grow as a person and to grow as a student and to move further.
Okay. So with moving further, all right, going to the next level, all right, so with your students, some of them are going into the industry, and then there's others are choosing the career path of, hey, let me go to college. So with that being said, do you have articulation agreements?
Yes, so we do currently have an articulation agreement with Indiana State College for their robotic and photonic program, which is a 2-year associated science degree program, in which that program they learn the real technical side of how robotic equipment runs, programmable logic circuits, as well as photonics and lasers.
Okay. So as a CTE educator, career technical educator, all right, do you believe that it is important to have this program at the school and at the school level before they even have the opportunity to go to college or go into the industry?
I would say a lot more than important, because some of these fields these kids don't know exist. A lot of the smaller things with electronics and robotics, the kids don't know that they're there. So by being exposed to it at 9th grade, it opens up a whole nother set of career opportunities for them, of thoughts they can have and start exploring. Last year being the first year of the program, we had a lot of kids that came in that they really weren't sure what they wanted to do. By the end of the first year, they were choosing areas in engineering and STEM, which was a big difference from the start of the year.
Okay. So if we have a parent or guardian or even students that are watching this show, and they're like, hey, I want more information, or hey, I want to become involved in that robotics program, what steps do they need to do?
So the robotic program is a magnet program within St. Lucie County Schools. So if they're looking for more information, they could contact me directly at the school via my email. Or what they would be able to do if they wanted to apply for it directly, they would need to contact the student assignment department and apply for the magnet program at Fort Pierce Westwood Academy.
Okay. Is there anything else that you would like to share about the items that you brought in?
So again, a lot of these items are student created. So that is kind of the peak of our program. It's not just showy, hey, look what we got. It's look what our students have done, which I think speaks volumes, rather than saying, here's something cool. Here's what our students done, which is important.
Okay. So with the skills gap in robotics, is there a need for workers? Is there a need to hire for businesses looking for students or graduates or even individuals interested in the career path?
Specifically in the area of electronics and robotics, yes. Within an hour north of this area, there are many companies, as right now with the Space Coast growing as it is and more things going into space, more satellites, more things with technology. Those companies are hiring constantly. There's always job fairs going on. They are always looking for someone with a basic entry-level set of skills that they can train. Because once you understand the basics of electronics, they can train you to do the other aspects of it. And those jobs are higher paying than some of the entry-level jobs, which is a good opportunity for our students.
Okay. So with that being said, as we're preparing to close, I want to recap on a couple of the main highlights, such as how many college credits can students earn by being a part of your program?
I believe the statement for it was between 6 and 9 credits.
And then if they go to IRC or Kaiser, they basically can also get those 12 mandated credits that the state has actually said, hey, you could actually have these credits, right?
Yes.
Okay. All right. So with students involved in this program, they also have the opportunity to be involved to actually use their skills and apply it at the next level, which is the Robotics Club, right?
Yes. So right now we have my Robotics Club is composed of we have 12 students right now. 6 of them are Robotics 2, 6 of them are Robotics 1. So we have our Robotics 2 students who are acting as mentors to our Robotic 1 students, and they're teaching them the aspects of this equipment here.
Okay.
So.
All right. And then you also mentioned that there is a website that you have for your students and also anyone seeking information.
Yeah, so the student assignment, St. Lucie Public Schools, they can get information there if they want to apply for the program directly, or they can visit the website for Fort Pierce Westwood Academy, which is also through the St. Lucie County Public School website. And we have several things up there as well.
Okay. Is there anything else that you'd like to add before we end?
I don't think so.
Okay. All right. Well, thank you for joining us today.
Thank you.
I'm Lanisha Robinson, and this is Career and Technical Education, #BuildAFuture. We encourage you to view our St. Lucie Public Schools Career and Technical Education page. In Career and Technical Education, we are merging the career pathways pipeline for each of our students. We are building a future and continuing to close the skills gap. On behalf of the station's team, I'd like to thank you for joining us today.